Hello students, in this video we are going to discuss about superposition theorem. The superposition theorem is based on the superposition principle which you have already studied in physics at +2 level. At that time this superposition principle was applied to find out resultant of two waves acting simultaneously in a medium. But right now we are applying the superposition theorem in these electrical circuits in order to find out the combined response when two or more than two sources are acting simultaneously in a circuit. As far as statement is concerned, the statement of superposition theorem is like this. In any linear active bilateral network containing two or more than two sources, the current flowing through any element of the circuit can be determined by considering the algebraic sum of current produced in the same element when each source is considered separately, with all other sources are replaced by their internal resistances. So while considering the superposition theorem, here we are going to deal only with the independent sources. By saying independent energy source, I am referring to the energy sources in which the magnitude of source is independent of the any other parameter of the circuit. So mainly we are going to consider two types of sources. One is voltage source and other one is current source. The voltage source usually represented like this. There are two plates, one is of unequal size. The larger plate is for positive potential and the smaller plate is for negative terminal. And for ideal voltage source, the internal resistance is 0. And normally, whenever we have to replace such voltage sources, it is replaced by short circuit. The another type of source is the current source. Current source is represented by an arrowhead. This arrowhead points in the direction in which the current is flowing. This is current source. Say this is of 5 ampere. So it means from this point, 5 ampere current is entering into this circuit, and depending upon the geometry of the circuit, that current of 5 ampere is distributed along the entire elements present in the circuit. And from this particular branch, the same amount of current is flowing outwards to the circuit. As far as current source is concerned, the internal resistance of a current source under ideal condition is infinite, and whenever we have to replace a current source, it is replaced by open circuit. So we are having now we are going to discuss the application of superposition theorem. With the help of this theorem, we are going to solve a given circuit. So this is the circuit on which we are going to apply superposition theorem. The statement of the question is like this: find the current in 10 ohm resistance using superposition theorem. Here in this question, we are having two different energy sources. One is a battery of 60 volt potential, and this is the positive terminal of the battery, this is the negative terminal. And here is a current source. Current source is having magnitude of 30 ampere, and we have to find out current in this particular resistance whose value is of 10 ohm. So while applying superposition theorem, we have to consider one source at a time. So step by step, we have to consider sources, and whenever we consider one source, all other sources should be replaced by their internal resistances. So by the application of superposition theorem, we can solve this circuit like that. Moving to the next slide. Yes. So here we are considering 30 ampere current source. So this is step 1. We are considering 30 ampere current source, and when we are considering 30 ampere current source, the voltage source is which was earlier present in this particular branch, it is replaced by short circuit. We are assuming that this voltage source is ideal in nature, as in the question, no internal resistance is given, and once when no internal resistance is given, this was the question. So here, no internal resistance of the sources is provided. So whenever no internal resistance of source is provided, we consider that is to be ideal case, and in ideal case, internal resistance battery is zero, internal resistance of current source is infinite. So in step one, that's why this battery is replaced by the short circuit. Now, once there are the modified circuit is shown here. Now the current from the 30 ampere current source is clearly from this node is divided into two different parts, and in the desired branch, I1 current is flowing. I1 is the current flowing in 10 ohm, and we can calculate this I1 simply by using current divider rule, which states that the current in the desired branch is total incoming current divided by sum of resistances of parallel paths. Here 30 ampere current is divided in two parallel paths. One path consists of resistance of 20 ohm, another path consists of resistance of 10 ohm. And we are interested in current in 10 ohm. So current divider rule states that current in any branch is total incoming current divided by sum of the resistances of parallel paths and multiplied by resistance of opposite branch. So whenever current is divided into two parallel paths, so we follow this relation. So by using current divider, here 30 ampere current is divided into two parallel paths. One is path of 20 ohm resistance, other one is path of 10 ohm resistance. We are interested in 10 ohm resistance current. So I1 current is total current divided by sum of resistances of parallel paths multiplied by resistance of opposite branch, and opposite branch is 20. So we can see due to source number 1, current is 20 ampere and direction of this current is in upward direction. By saying upward, current is flowing like this, upward in 10. So step 1 of superposition theorem is completed. We have solved the circuit for 30 ampere current source, and while solving, the other source is replaced by its internal resistance. Now moving to the next. Now this is the step 2. In step 2, we are considering the battery. 60-volt source is considered, and while considering 60-volt source, the current source is replaced by its internal resistance. We can clearly see that these two terminals are open circuited because internal resistance for current source is infinite, and due to infinite resistance, this branch is kept open. Now, as the middle branch is open circuited, now we are having a single loop present in the circuit, and from this we can easily calculate current in 10 ohm. Here in this circuit, 20 and 10, these two resistances are in series, and the current flowing in the desired resistance, that is 10 ohm, I2 current. I2 is the current in the desired branch due to source number 2 is 60, the voltage divided by total resistance. This is 2 ampere, and its direction is down. Now moving to the next step of superposition theorem. What we will do, we will algebraically add all the responses. So the total current, this is total current when all the sources, both the sources are acting simultaneously, is sum of individual responses I1 and I2. While adding these two responses, we have to consider their directions. So 20 ampere current was in upward direction, but 2 ampere current was in downward direction. So the net current is 18 ampere and its direction is in. So when both the sources are present in the circuit, and in this circuit, when both the sources are present, so the current flowing in 10 ohm resistance is total current I is equal to 18 ampere, and this current is in upward direction. This is how, by using superposition theorem, we can easily calculate the response when two or more than two sources are acting simultaneously in a circuit. Thank you.